implementation. And finally, I'll talk about how you can use the tools and services in our setup to troubleshoot build failures. So when I say CI, what I'm referring to is continuous integration. FHIR is a standard, but at the heart of that standard is a group of open source projects. And FHIR is an interesting open source project because the contributor community is quite the mixed bag with varying levels of technical experience. But even so, at the end of the day, at its most basic view, we still have groups of community members committing changes to a shared repository, often as frequent as on a daily basis. And because of this, we're still going to encounter a lot of the same issues and difficulties that you would expect to find in a typical software project. People do their work on their own features independently. Developer A could be making changes to types for value sets or code systems, and developer B could be doing some kind of updates for R4B. And they don't know what the other is doing. And these are just two of many developers working on the same code base concurrently. This is where continuous integration comes in. We want to create automated processes to check the state of our code and provide quick feedback to contributors on if their changes will work for them, and more importantly, ensure that the build continues to work for everyone. This centers around one of the core concepts of CI, which is reducing the code delta. So what do I mean when I say code delta? Well, as a contributor, you need to clone the repository you want to make changes to. This clone represents the code base at a given point in time. After cloning the repo locally on your machine, in an ideal world, you could take all the time you needed to experiment, learn, make changes, and finally, once you're confident in the changes that you've made, push that code back up to the repository for other people to consume. The only issue with this is that we do not live in an ideal world. There are many other contributors making changes to that same repo at the same time that you are. They could be modifying the same files or modifying files that directly affect the changes that you're making locally on your machine. These differences in changes are what's referred to as the code delta. And if we don't resolve this, it can end up causing you lots of frustrating errors that I'm sure a lot of contributors here have experienced. And this brings up one of the most counterintuitive concepts in continuous integration, and that it's a lot like working out or going to the gym. If it's a horrible experience when you do it, and it's something that you really dread doing, you're probably not doing it enough. We want to put an emphasis on quick iterations and immediate feedback. So how do we do this? Well, we want to encourage contributors to focus less on large, long-living tasks and instead provide tools that let them get feedback on small, iterative changes so they can merge easier and, more importantly, share their work with others. I'm going to use the core libraries as an example, but the approach here is similar across all the other HL7 code bases as well. When a user opens up a pull request on GitHub, after a delay for processing, GitHub will let them know if their changes are okay to merge, or if they need to make updates before being allowed to do so. But how does GitHub make this decision? The truth of the matter is that GitHub actually doesn't do any of the decision making here. We rely on an external Microsoft tool called Azure Pipelines. Under the hood, Azure Pipelines does a few key things for us. First and foremost, it detects triggers that we define for it. This could be someone opening a pull request in GitHub, someone merging their branch into master or main, or a manual trigger of some sort. Then Azure will run predefined tasks for us on a series of customized virtual machines and provide us with feedback in the form of Zulip messages, GitHub posts, or emails. And the best thing about this system is that it's free for open source projects, which is great for such a powerful tool and perfect for us. So in our process here, the first thing Azure is going to do is spin up a set of predefined VMs. As of now, I've set this up to target 3 of the most common operating systems available in hopes that this will cover most of the users that are out there trying to build the libraries. After spinning up those VMs, we just run a straightforward Maven build. The VM installs Java and then Maven, and finally downloads and installs all the necessary dependencies to build the project. After this, we run a suite of test cases for the project and generate reports based on those test outcomes. And finally, I've just added logic to build and test any Java programs produced by these builds. So examples of this would be the validator CLI or the IG publisher. We were having issues where contributors were committing code that built and it passed all the unit tests, but resulted in a broken validator or IG publisher. I'm hoping that adding this check at the end will reduce the frequency of this happening. It's important to note that despite all the steps and the 3 different test environments, this is an entirely binary operation. It doesn't matter if all the steps fail or if a single step fails. Any failure at any point results in the entire build being rejected and you not being able to merge. The only passing case is when we have every single step marked as successful. I understand that this can be frustrating, and it often leads to exchanges on Zulip where people will send me messages letting me know that the build works on their machine. And I understand that this can be a really crappy situation to be in. But what we're trying to do with these pipelines is provide a baseline. When it comes down to comparing your home or work computer to the processes running on Azure Pipelines, your computer could have any combination of hardware or software on it. Also, there could be build artifacts or dependencies from previous builds kicking around that are affecting the state of your current build. I have no way of knowing what's going on under the hood. On Azure Pipelines, we create the equivalent of a brand new computer for every build. This involves doing a clean install of everything from the operating system to Java itself. And by running it on all 3 major operating systems concurrently, we ensure that no platform-specific bugs are introduced that you may or may not be aware of. And this all sounds great, but I'm sure the majority of contributors are more interested in knowing what they can do when a build fails for them. So the first thing to do is to go to GitHub and see exactly where it's failing. For each of the checks the pipeline's doing, there's an option to select the details button here to drill down further. When you're viewing the details, it'll give you a little more information about the exact job failure, but there's not really anything too great here. What you want to do is view the pipeline itself. To do that, you can click the link at the bottom of the screen, and that's going to take you to our Azure Pipelines page. Here you can see the detailed steps we execute on each VM, and more importantly, you can click on the step in the list that failed and view the actual log to the right. This is where I start debugging every time I see a build failure, and if you're stuck and you reach out to Graham or me for assistance, this is the log that we're going to ask you for. So that was a super quick overview on how we handle integration. The other half of CI/CD is continuous delivery. At the end of the day, we have our code on one side and we have our implementers on the other. How do we turn this code into published executable programs? Or in the case of our core libraries, how do we publish those libraries for other people to use in their own projects? So historically, we had a very dependable system, but it relied on manual steps. Graham needs to sleep and spend time with his family, so we've automated it, similar to the way in which we've automated our integration process. More specifically, we reduce it down to a single button click in our Azure Web Console that a group of users has permission to press. The idea of a single button click deployment is important because I think one of the biggest things that people struggle with, especially in large, slow-moving industries like finance or healthcare, is that if it takes you days or worse, weeks to deploy changes to your system, and that deployment depends on multiple teams or a series of hard-to-obtain approvals, any emergency fix or patch that needs to be deployed quickly will be equally as painful to get out the door. And we want to be able to move quickly when needed. So what does that actually look like for the core libraries? As with all our examples, we'll start with our code repository. Every time a branch is merged into master, we create a snapshot build. This is a mutable published release that we upload to OSS Sonatype. This snapshot can then be pulled down or tested or used in any project by anyone. It's important to note that you should never release any software with a snapshot dependency in it, as it can be changed or overwritten at any time. Eventually, it'll come time for an actual release, and when that happens, one of the group of developers with admin privileges will go and press that Run Pipeline button in Azure. Once that happens, a series of steps takes place. First, we do a full, stable release to Sonatype. This, unlike a snapshot release, is immutable. Once we release a version 1.2.3, there will never be another 1.2.3. There will only be 1.2.4 or greater. The behavior will remain consistent. Next, we send a notification to the tooling releases and committers notification channels in Zulip. This message includes the release number, generated release notes, and more importantly, links to the release artifacts. Finally, we upload the release to GitHub. If you log into GitHub and go to the org.hl7.fhir.core project, you'll see on the right here the heading Releases with the latest release number listed underneath. You can click on that title and be taken to the list of all releases for the project. On this page, you're going to see the version number, the generated release notes, and finally, any produced build artifacts. In the case of the validator or publisher, this is where you're going to find the latest release of the validator CLI or the IG publisher tool. These deployments are handled by Graham and his team, so debugging is not something most users are going to have to deal with here. In the case of the core specification at build.phir.org, the process is a little different as we're deploying a web page. Every time a user opens a pull request to the master branch from their local branch, if that PR builds successfully, we generate and upload a copy of the web page from their branch to build.phir.org/branches. If you navigate to that website, you'll see a list of all currently built versions of build.phir.org, and you can click on them to browse and validate them, as you would the normal build.phir.org website. Once we're satisfied with how the generated page looks and the build is passed, users will either merge their changes into master or R4B, depending on the FHIR version that they're targeting. On a successful merge, we send a message to the Zulip committers notification channel to let people know the status of the upload. And then in the case of master, we upload the built web page to build.phir.org. Or in the case of R4B, we upload the built web page to build.phir.org/R4B. The process for debugging failed builds is similar to that which I outlined for the core libraries. All of the logs are available to view. I also want to acknowledge that contributors to the specification are often not people with technical backgrounds. And tools like Git, Gradle, and Maven can be intimidating and confusing to use at times. So I'm doing my best to create documentation to assist in these processes at hl7.github.io. That being said, that was a lot to cram into 15 minutes, so I'm going to leave my contact information here. Feel free to reach out if you have any questions or need assistance or support. I'm always happy to help. Thanks again for taking the time to come to my talk today, and I'll open it up for any questions that you might have.
I actually have a question, Mark, and I don't know if you covered it. I don't know if it's maybe a little tangential or it's somewhat related, I think, at least to what you've been talking about. And I've got a situation right now, and I've had similar ones before, of course, but we're trying to, put in, get a new version of the concept map resource in the FHIR, core build, but it's got dependencies on, on FHIR core, and for trying to navigate the easiest way to do that without dumping it in Graham's lap is a bit of a challenge. So do I reach out to you to get any help with that, or what's the best way?
Yeah, when it comes to like those kinds of build, you can hear me, right?
Yeah.
Okay, when it comes to those kinds of build issues, in terms of the actual nuts and bolts of getting things to run, I can definitely help you with that. If you had questions about the concept map changes you were making, that Graham is of course the best person to go to for that.
I'm fine with the concept map changes. It's just a matter of coordinating between the various build projects, and I can slog through it myself, but it's tedious and probably not doing it, sometimes it's, yeah. Anyway, probably could use a better strategy. So
Well, yeah, feel free to reach out. Maybe we could have a little pairing session on that. I can give you some help.
okay.
Everyone should be able to unmute themselves if you'd like to ask a question. I don't see any in the Q&A in Whova just yet.
Hi, Mark. This is Lloyd. There's one other piece of the publication machinery that isn't under your custody yet, which is the templates used by the IT publisher. Do we want to tie them into this CI build process as well?
Yeah, I think the goal is to eventually have their own process, but like as you're aware, it's a little different when it comes to publishing implementation guides and that. So I think Graham has a general idea of how we want to approach that, and we've talked about it a few times about what's the most intelligent way to automate what people are doing now, while not like providing too much shock and change to the way people are doing it as well. So that is something on our radar for sure.
Okay.
So no one's asking any questions. I turned up at the end of Lloyd's question, and so I don't know what he actually asked, but I just wanted to say that the thing that's fascinated me about Mark's work in the last year is just how long it takes to get these pipelines nailed.
There's a lot of moving parts, and I think half of it is I'm coming into it without knowing exactly how everything works. So to automate something, you have to first learn what it's doing and what the expected outputs are, and then automate the process. And so I'm hoping that this will eventually pay off, and that I'm making your life easier and not not the opposite.
Oh no, it's paid off.
Any other questions for Mark? We have about 2 minutes left in the session.
Thank you.
No problem. Thanks for coming. I had tough competition. I know Google is giving a talk, and Josh is giving a talk in another room too, and he gives a great talk. So I appreciate you coming.
Well, I don't know if they're going to have animations as good as yours. And you had a very nice speaking voice as well. So thank you, Mark, for taking the time today. And thank you, everyone, for joining us. Please remember to rate your session in Whova, and have a great rest of your day. Thanks.
Thanks, everybody.